This is a pre-built version of the application. So if we go ahead and run it, now suppose you are building an apartment matching system, and based on rent, size and location criteria, you want to be able to predict a potential new renter sentiment reaction as being positive, negative, or neutral. And suppose that x1 is the rent in dollars, and x2 is the size in square feet, and x3 is the distance to downtown in miles, and x1 prime, x2 prime, and x3 prime are their normalized values. And here we are using min max normalization. So the normalized rent x1 prime is equal to x1 minus the minimum rent over the maximum rent minus the minimum rent. And same for the size and distance to downtown. And suppose we have an apartment with this rent and this size and this distance to downtown, and using the three nearest neighbors, and we want to predict a potential new renter reaction. And here we are calculating the Euclidean distance in order to compare the normalized input features to the features in the dataset. And this is normalized rent input, and this is normalized size and distance inputs. And we find the three nearest neighbors and take a majority vote. So it was classified as negative sentiment. So we predict that the potential new renter will not like the apartment. I will start by creating a new project. And here we will have four classes. A driver class with a main method, and this class that will contain the k nearest neighbor logic, and this class that will contain the display code, and this one for matrix helper code. Now going to the driver class, this will be the training data that we will be using. So this column is the rent in dollars, and this one is the size of the apartment in square feet, and this one is the distance to downtown in miles. And this indicates liking the apartment, and this disliking it, and this being neutral. And we put the training data in X array and Y array for the label. and to do matrix operations we need to use commons math library. So we already used it on this project, so let's copy it and drop it here. Go to properties and Java build path, and we will initialize x and y using this constructor. So x is passed as a matrix, and here we will have this static method that handles the command line entry, and we will call it from here. And this will contain the minimum and maximum values for rent, size, and locations. And this would be the range x max minus x min, and this would be the normalized values. And we will initialize x min and x max to the first row, and we will have this method that calculates and returns the range, and in the process it will calculate x min and x max, and we will call it from here. And this method does normalization, and let's go ahead and define this method that does division on two matrices. And we will end up calling the normalize method from here, and let's go ahead and define those get methods for x, y, and x min, x max, and the range, and the normalized version of x. And here we will have this code that does display. And we will have a reference to this class here, and we will initialize it in the constructor. And let's go to the matrix helper and add those methods. And here let's define this private method that sorts the Euclidean distances, go up here and define this, and this method does classification, and in order to do that it calls on the sort distances. So this matrix have the normalized input, and this one has the Euclidean distance, and here we will have this static method that does display of the classification information, and we will end up calling it from the handle command line method. And let's simplify this. So here we prompt the user for an entry, and we parse that entry, and here we are doing the classification and displaying the classification information. And finally, let's go ahead and test run the application. So x1 is the rent in dollars, and x2 is the size in square feet, and x3 is the distance to downtown in miles, and x1 prime, x2 prime, and x3 prime are the normalized versions of x1, x2, and x3, and y is the observed sentiment on our training data. So plus indicates liking the apartment, minus indicates disliking the apartment, and this indicates a neutral reaction. So let's try to predict a potential reaction if we have an apartment with this rent in dollars, and this size in square feet, and this distance to downtown in miles, and the three nearest neighbors. So those are the three nearest neighbors, and if we take a majority vote, we end up with a potential negative sentiments, so will not like the apartment prediction. And this is how we calculate the normalized rent, and this is how we calculate the normalized size, and this is the normalized distance to downtown. And here we are calculating the Euclidean distance.